Good morning, ladies and gentlemen. My name is Petr Doležel. I am from University of Pardubice, Czech Republic, and I would like to tell you a few words about the paper called Counting Livestock with Image Segmentation Neural Network, which I wrote with some of my colleagues. Well, the paper I'm talking right now about is the result of the work of our research group. We deal with especially quality control using computer vision, object detection using signal processing, and part of us deal with intelligent control systems. Well, let's talk now about the motivation of this specific paper. Well, our research group is in touch with several long-term contractors from agricultural companies. We already solved for them situations or problems like pest bird detection using sound processing or yield prediction from visual data. Right now we are dealing with precision agriculture issues, and this particular paper is about the precise and up-to-date information about the position and number of the animals at agricultural farms. So in simple words, our contractors need to count and position animals at farms. There are several solutions which can be chosen to this problem. Of course, some of farmers use a manual approach, as you can see in this figure. Basically, a man with a pen and paper goes through the farm and counts the cattle, the animals. Or you can use periodical autonomous approach. So each animal has some chip on its body, like this color, and you can periodically count animals going through some narrow point at the farm. And these days I think that the most advanced approach is the third approach, which I called continuous autonomous approach, which is based on this figure you can see here. So we can apply drones or UAVs to continuously fly through the farm, and using mosaicing to somehow connect all the images made by drones, and then we can perform image processing for correct positioning of each animal at this big image. In this particular paper, we deal with this part of the scheme. So, as an input, we consider big image, and we want to precisely position each animal in this image. For our solution, we consider various types of background. We consider different size of animals, and of course big variance of animal numbers, including crowded animals. Examples of the images can be seen in this slide. So, according to these prepositions, we proposed specific solution based on neural networks. As an input for our algorithm, we consider RGB image, and then we try to provide convolutional neural network which transforms this original image into schematic image, as you can see here. This image is composed of white spots which represent each animal, and black parts of the image which represent everything else. Then, if you have such image with white spots and black background, you can easily locate the positions of each animal in this transformed image using simple local maxima function. And when you find these white spots in the image, you can locate each animal, and then you can of course count them. So the main trick of our paper is the development of proper convolutional neural network which can transform original RGB image into this schematic image with white spots. For our pilot study, we chose the family of image segmentation neural networks. These networks can transform original image, input image, into this segmented image where each object is highlighted with a different color. Well, our issue is a little bit different. We've got original images with many kinds of objects, but we want to highlight only animals, sheep or cows, not bushes, trees, and so on. So we performed several tests, and according to our results, we chose UNet because UNet provided the best results during our pilot studies. Of course, we also needed to acquire proper training and testing set for the UNet training. So we shot 10-15 minutes of a video with cows and sheep. The statistics of the images we took for the training are summarized in this table. And we performed a set of training sessions. In this table you can see the hyperparameters of the training we used with our UNet. These parameters are set according to our previous experience and results of the pilot study. And after training, we evaluated our UNet using some well-known matrices as accuracy, precision, and recall, and the results are summarized here. You can see that for the training set the results are outstanding, but there are good results also for the testing set. This testing set was not used during training, and still the results are quite good. Then we somehow split the data according to the distance between drone and animals, and according to the numbers shown here, there are not big differences in the accuracy if the shot was taken from low distance or high distance. So, as a conclusion, I can tell you that a somehow novel engineering approach to livestock positioning and counting was proposed, and it was based on fully convolutional neural network. According to the results of our pilot study, this approach is not really sensitive to the background, to light conditions in some way, and it is not sensitive to animal size, which is good, because then the drone can fly in low distance as well as high distance from the cows or sheep. So, thank you for your attention, and if you want to contact me, use this email please. I will be happy to respond for any of the questions. Thank you again.